in the past. Is this correct? Or this was not you?
What about program?
I think that some of the analog inputs or digital outputs, inputs and outputs, or something like this.
All of them have models, input output.
Sabata group children's camping. Is this something that tells you something, or?
What?
Sabata group children's camp. Is this something that you know or not?
I am SBT group.
SBT group. Okay, so this is for you.
All of all another. It's our partners.
Okay.
We want to teach them.
Okay, good. So I'll share my screen and start. So how familiar you are with programming?
I wouldn't really programming, but I will be here to help if it will be necessary.
Okay.
Two guys have all equipment and task to teach.
Okay. So the training will be about 4 hours. So we'll go through the MCA, the basics of the СмартеХ, and then we'll go through the LPC programming and
Good.
that's it.
The volume, it's up to you. If guys will have some questions, they ask you.
Okay. So the program for the creating the configuration is called СмартеХ. This is what I have sent you yesterday, and basically when you install this program, also Beremis is installed when you install the СмартеХ, and СмартеХ is for creating the configuration and adding the controllers and modules to the controller, and then Beremis is for programming the code and in structured text and ladder diagram and these languages. So that's about it. So in this СмартеХ, this is СмартеХ. Do you see my screen or not? Oh, someone is sharing screen. Okay. Can I share my screen? Hello.
How about
Or do you recommend that you go that you open the Beremis and to watch on your computer?
I see 3 participation.
What are you trying to do? Below.
А что мы хотим сделать?
Так, друзья, вы что-то видите там?
Ну, сейчас только экран Дениса.
Вот, и
Ну,
черненький,
его
да?
скайп.
Да. Угу.
Вот теперь этот LPC
Вот,
СмартеХ
да, появился, да. Угу. Денис, окей.
Yeah, you can see my screen now.
Yes, we can see.
Yeah, so okay, this is the СмартеХ which I sent the link yesterday. So basically how everything looks is that you have on the here you have projects, so you can create new project or open an existing one and also save the project. And on the left side you will see that you have the main modules, which are the most used one is MC8 and another few of them. Then you have network modules to communicate with different protocols. Also communication modules. I will just if you want to add the controller to the configuration, just click on the MC8 and then right click on the add module, and then as you can see it will add module. And then if you click on another so here are the main modules, and everything below is the modules that are connected on the right side of the controller. So the communication modules, and if you click on the module, it will add on the right side, and it's DALI something, digital inputs, as you can see. Some of the 24 volts, some of them on 230 volts. Then you have digital outputs, analog modules, dedicated modules. Here are the dimmers in example, and also we have here the room modules, which are created for the hotel rooms. Because we have here a few digital inputs and outputs, and then also a few analog inputs and outputs. We have door lock and stuff like this. And also here we have intelligent peripheral modules, which are these modules are not connected on the right side of the controller, but are connected with the COM port, as you can see here. But I'll explain MC8 a bit later.
MC8, okay.
Yeah. So the intelligent, as you can see, it looks like this, so it's separated. And DP1 in example have the ability to set the temperature and the fan speed. And then these parameters are sent to the MC8 and you can use them.
Dennis, most of our application is HVAC application. So room and another missed it.
So HVAC is the fans and stuff like this. The air how to say? Yeah, I know. Okay, good. So we have also here the CH1 module, which is for reading cards, and CA1 module also for reading the cards.
Access control, we don't need it.
Okay, good. So the temperature and humidity sensor, communication card for infrared protocol, And that's about it. So, okay. So if we go through the MC8, which of the how it looks like. So MC8 have here the power supply connectors. Then here we have CAN bus connectors. As you can see, these 4, 5, 6, 7, 8. One is for CAN master and CAN slave, and low and high connect and the ground connector. Then you have here run and stop switch. This switch means that if controller reboots, and after reboot, if the program will go to run mode or to stop mode. So if it is in stop mode, the PLC program which is installed on the MC8 won't start, and if you want to start the program, you have to put it to run. Then you have here COM port. This is for this СмартеХ interleaf modules for let's say this temperature and fan speed module. Then you have here a USB connector for connecting to the to PC, and also Ethernet connector for the Modbus TCP protocol. So on the right side you have input and output modules. You can just plug it to this connector, and on the left side is something that you won't need, but just to know, this is for the debugger to connect to the MC8 and stuff like this. So okay,
Денис. Да, приветствую. Сейчас, ну, да, 2 минутки. У меня после сессии в скайпе несколько человек участвует. Да, угу. Да, слушаю. Угу. Ага. Хорошо. Я тогда все подниму, да, что там, если что-то поменялось. У меня, если ничего не менялось, то так и напишу, что все окей. Угу. Все, хорошо.
okay, so can you continue?
Yes.
Okay, so this is how the configuration looks, and let's say that we want to add another digital inputs, and just click on this module here, and then right click on the module and add module, and then we will add a few outputs, 3 outputs, and then right click on the add module, and that's it. So then you'll have to enter a description, which will be training SBT, and then click on save, and it will open the save window. We'll save it. And that's it. Now the configuration is prepared. So here also you can see what is the power consumption. So the 24 watts are the high limit for the. So I think that from 8 to 10 modules is the maximum that you can connect. And then to enter Beremis, you have to click on program, so then it will open the Beremis and the programming section of the PLC. So that's it. one more thing that it's worth mentioning, it's that if you double click on the MC8, it will open this configuration window. So here you can open the user manual of MC8. Then here, as you can see,
Денис, wait a minute.
yeah.
Дмитрий, Алексей, на этом этапе есть какие-то вопросы?
У меня пока нет.
Ага. Ну, все. Как только вдруг заметили, что не успели увидеть, что нажали и для чего, прямо сразу задавайте вопросы. Окей. Все. Угу. Let's go.
Yeah, so it's okay?
Окей.
Okay. So here you can change the MAC address of the controller, IP address, mask, and patch. So the Modbus TCP parameters you can change here and then set it to the MC8. Here also you can change a lot of the other stuff, but not needed. And something worth knowing is that here you can select the coils. Do you know something about the Modbus configuration, or you are not familiar with Modbus TCP? Okay, so that's it. So how the Beramis looks like is that here you have the can open what you have on right. So on right we should have two modules which we have added before. So the D5 and the D07 inputs and outputs, and that's about it. So here you have the can open configuration, but will you need the can open? So should we check this or not? Can
Это
open.
can open, это чтобы соединять два этих контроллера между собой?
Да.
А
Или
если их
другое
будет,
устройство по кану.
а если их будет сотня?
Ну, сколько...
Which of the communication protocols you will use? Can open, Modbus TCP, Modbus RTU.
Окей.
Which of them? Do you know or not?
TCP.
TCP, Modbus TCP. Okay, so good. So to enable Modbus TCP, you have to choose here the coils, holding register, discrete input, and input register. So the coils are the Boolean variables for sending. Discrete inputs are Boolean variables for reading. Input registers are word variables for reading, and holding registers are word variables for sending. So how much calls and other do you need? You can just enable here, and then it will enable this section of coils in the Beramis, so you can use these coils. And
Вот тут бы
so
пояснить, для чего это все.
Dennis, explain previous table. When you choose coils, what for?
this is just so, as you can see, we have marked here 1
Yes.
to 64 coils. So 64 coils are now enabled to use them in the program. But if you enable another 64, we will have 128 82 calls enabled in the program. So is it now clear? And also,
Wait a minute.
yeah.
Не знаю, что такое coils, да, но тут вот какое-то количество сигналов выбирается. Если нужно там 64, то вот он отметил 64. Если нужно больше, так и
Все
пошло.
понятно.
Угу. Окей, let's go.
Чтобы не
Okay,
перегружать количество сигналов, которые у нас проходят. Все.
Угу.
Yeah, that's about it. So the holding registers also the same protocol. So just enable what's needed. But do you know what's the difference between this type of let's say variables? Do you know the difference between the calls?
Он спрашивает, знаете ли вы разницу между этими регистрами?
Скорее всего, нет.
No.
You don't know, okay.
Yes.
So the calls are just for but the problem is that the MC8 is only working as a slave. So the Modbus RTU slave. So calls are used for sending and reading the Boolean variables. Holding registers are used for sending and reading word variables. Discrete inputs are for only reading word variables, and input register also for Boolean variables reading. So that's it. Hope that it's more clear now. But we will check this also in Baramis. Maybe it will be more clear. So this site is now, we went through this. So if you click on project, it will open the project. So right now, as you can see, we have empty. And if you click on plus button, we can add a new data type. The data type is, let's say that we want to add new Boolean type. We will add a new data type. The function, which is basic function, then the function block, and then program, and resource. Resource, I never use this. The main two things which you will use is program and function block. So let's start with the clicking on program. I missed. Clicking on program. So now it's opening the name of the program, which type is the program, and language. I will put it into ladder diagram. Okay, so as you can see, it appeared here. The program appeared here. So now when the program is added, we have to add it to the resources, so the controller will know that this new program which we have added is running on the PLC, on the MC8. So to do this, you have to open the resources. So here you have three windows. The first one is for global variables. The second one is for tasks. So by default, it's main task created and interval is 50 milliseconds. This means that the PLC is working, is running every 50 milliseconds. But if you want to add a new type of task, just click on plus, and we can add, I don't know, communication test. Communication task, let's click, and then we can choose here the time, let's say that it is from 10 seconds. So now we have two different tasks. One is running on the 50 milliseconds and another one is running on 10 seconds. And here is also the priority. So the lower the priority is, this program will run first. Okay, so next we have instances, and this is where we assign the program to the specified task. So if you click on plus, it will open the name. I'll name it main as the program, just instance before, and then type it is program main, which is the same name as my program. And then the task, we can select which task is assigned to this program. So if I click on the main task, it will run on 50 milliseconds, but if I click on communication task, it will run every 10 seconds. I hope that
Сергей,
this
вот чуть-чуть бы пояснить, что мы делаем. Что-то я потерялся. То есть мы выделили какой-то ресурс таска, вот это вот что мы делаем.
Dennis.
Yeah.
What is the aim of these operations?
What do you
what
mean?
What are you doing now? What for?
So this is that the program we have added here. This program won't run if we don't add it under instances. If you understand. So we have to add it here under instances, so the program will know that it has to run every 50 milliseconds. But if I delete this instance here, the program won't run on the PLC.
Если этих инстансов не будет, то не запустится PLC.
So let's say that we have here two programs. I will add another one.
То есть нам под каждую надо выделять ее?
So if you have like this, so I just added a new program, but this program won't run on PLC. It's just it just appeared here and it's doing nothing on PLC. But if I add the program here, like this, 2, and then let's say that now it's the communication task. This program is now running every 50 milliseconds, and this program is now running on every 10 seconds.
Mm-hmm.
Is it clear?
Понятно?
Да. То есть какое-то выделение ресурса под каждую вот эту программулинку.
Да. Окей.
Okay, good. So that's about it. So the difference between the global variables and the local variables, do you know the difference? The
difference between
difference between local and global variable, yes. The local variables are used only in one of the program.
Mm-hmm.
But if I create here, if I click on plus and let's name this global variable, this global variable can be used in both programs. But if I just create it here, the variable, it will only be in this program. Okay. So I forget to mention how to add the variables. So to add the variables, just click on here. So now we are inside of the program. If we click on plus button, it will appear here. And let's say that we want to add a new Boolean variable. So let's the local. So the variable is local, and then you select the type. You choose the base type and click on bool, and that's it. So this is how to create the variable, and so this one is the local variable which I have created here in this program pmain, and here we have the global variable. And to add this global variable, just go to the program main, click on plus, and then name it as a global variable, and then select the class external. So this means that the variable is global, and we just select the same type as here, which is double integer, and that's it. And now we have one local variable and one global variable. And also this global variable can be added here in another program. The same procedure, and that's it. And now we have the same global variable used in the both programs. Okay.
Yeah.
So to use these variables, there are a few types of adding them to the program. So this here is the variable section. You can just click on plus, and it will add a few of them. And under here, as you see this line here, under the line is the programming section. So there is a few types of adding the variables to the program. So if I click on the number and drag in here, it will the Boolean variable will appear here, as you can see. And let's say that we just have the one output, and to create the output, you have to click on this new coil here, and click this, and click on the programming section, and it will open the new window. And then you have here a few different types, so the negated, rising edge, falling edge, and stuff like this. And then you select here the output variable. And then to connect everything together, you just have to add these power rails on both sides. So click on the power rail, so create left power rail, then click again and select also the right power rail, and then connect everything together. And that's how you create the program. Okay. So for the training, I will just delete this program. So main2, I'll delete this one, and also the instance. So now we have the basic program programmed. So if you want to install the program to the controller, you have to build it. So to build the project, you have to click on this icon here. So build, and then you will see here under the console section, it started to build. It will take some time, but nothing. So as you can see, it's successfully built. So the one more thing that is that you can simulate the PLC. The MC8 has the ability to simulate the PLC without the real PLC. So if you click on simulate, okay, so now the program is running. And if we click on these glasses here, it will open the debugger window. So like this. As you can see, the time is running here. And if I click on if I right click on the Boolean variable 1 here and force the value to true, it will trigger the output to true. So also if I double click on this line here, it will okay. It will open here the variables, and also we can put it to the graphs. So if I again force the value to false, as you can see, the output went to false.
Во, Сергей, вот тут как раз и вопрос-то у меня был, который я написал. А можно сделать, чтобы сделать ее меняющейся переменной? Не так 1,0 там, допустим, а чтобы она сама там пилообразно или там через какой-то промежуток делалась эта переменная, чтобы в динамике ее смотреть.
Ну, давайте сейчас пропустим этот вопрос, пойдем дальше, а потом вернемся, окей?
Да.
Let's go.
Okay.
Here there is some question, but we will return to it.
You can just ask if you want. It's up to you. If you want to ask, just ask.
No, go.
Okay. So this is how the debugger works, and if we just so now we have the local variables, which are some of the local variables used in the program, but here under the topology, not under the project, we have the right bus, which are the two modules, these two modules, DI5 and DO7, which we have added here. They are also present here under the right bus. And then, as you can see, if we click on plus, so DI5, which is the input module, we have a few inputs here, 8 inputs. And under the DO7, we have outputs, we have 8 outputs. So, if you want to use this variable inside of the program, you have to click on the plus button here, and then let's put it to local, okay, and then click on the location. No. Okay, maybe just okay. So to use these variables, just click this input and drag it inside of the program. The name will be the same as here, and just click OK, and yes. As you can see, this variable now is now here, and also the location. The location is the location of the input of the DI5.
Сергей, я правильно понимаю, что вот тем переменным, которые мы сделали руками, нельзя присвоить входы-выходы? То есть location там не активно?
Я затрудняюсь сказать. Так, еще раз.
Ну вот сейчас Денис пытался вот эти переменные, которые мы объявили, вот, пытался присвоить ему значение входа-выхода. И это не получилось. А так должно быть? Или все-таки мы можем там переменные сначала себе, ну вот накидали там булинг, input, output, да? А теперь к нему подставить вход-выход физический. Или только вот надо вот этот вход-выход физический только сюда перетянуть, и он объявляет свою новую переменную.
Я-то в этом вообще ничего не понимаю. Да. Я просто соучастник. Так.
Так, как объяснить тогда?
Так, давайте сделаем так. Пусть он расскажет до конца, да? Вот. А потом мы...
Потеряться. Боюсь потеряться в вопросах.
Не, прямо скриншот делаем, да, вот, и на нем пишем вопрос, вот. И я все саккумулирую,
Да.
Да, и мы все заново пройдем. По ходу, если возникают вопросы, просто...
Ну, я себе помечу, а потом попытаюсь
фиксируйте.
написать, да.
Да. Все, если надо приостановить, типа там, ну вот процедурно.
Нет, все, я понял, я себе запишу. Все, я не буду тогда, извините.
Все. Да, потому что, к сожалению, я в этом ничего не понимаю. Вот, поэтому так вот сходу, чтобы мы это решили, это просто сильно затянет.
Окей.
Денис.
Yeah.
We will accumulate question and ask you in the end of session. Okay?
Okay, good.
Or we will send you all our questions and you ask, you answer.
Okay, good.
Okay, let's go.
Yeah, so now we have added inputs. So this input is first input of the DI5. So input 1, as you can see here. And if you want to add another output, let's say that L1, this is the first output of the DO7. We just drag and drop here also this variable, and it will add a new output. And then we can add a new rails, but usually I just use the same rail if I have more options. So now we can build it again, the project build again. Okay, maybe this is the problem. I usually program on the MC9, so okay. Just delete this one. No such file or directory. There's a problem. Just give me a second. Let me just delete these two. And let's see. Strange problem. Before it was working okay, and now it's... maybe I have to stop it. No, That's the problem. Okay. So you have to first stop the simulation of the PLC and then you have to build the program. Okay, so again, if we go to topology and then add input from the DI5 and then output, connect them together and then connect it to power rails and then build it again. Okay, so now it's successfully built. And if I click on simulate again and go to the project and click on these glasses again, it will open the debugger. And now if I debug the output from the DO7, and if I set this to true, the outputs from on the DO7 is triggered. And back to false, and went to false. Okay. So now I think that's about. So what do you need to know about the barem is also here on the right side. We have here the standard function blocks, which are the set, reset, rising edge trig, falling edge trig, and timer on delay, timer, basic timer, timer off delay. So if you need one of these standard function blocks, just drag them inside of the program. And as you can see also it's added here, the type is timer off. And let's say that that we want to use this timer. So to delay the output of on the DO7, we just put here this input, connect it to the output, and then we have to add a new variable. So if you click here on the T off or double click on the timer of delay, here is a few informations about. So the Boolean input must be this input must be a Boolean type. So the PT is the time type, and the output is also Boolean, and the ET is time. So to add new variable, which will be time, just click on the create new variable and then click inside of the programming section, and then just write here T, how to say this this symbol, and I don't know how to say, but okay. And then let's say 10 seconds and click OK, and then this variable appeared here. And then
это вот решеткой мы задаем временные отрезки, правильно? Все это мы сейчас вот переменную в 10 секунд туда подставили. Или таймер на 10 секунд.
Dennis, is it a timer for 10 seconds or variable 10 seconds?
So there are two types of creating the time variables. The first type is like this. So you put here, just click on the variable and then select it here and then write this. This is how the barem is understand that this is the 10 seconds. So this is the time variable, and also there is another option. If you click here on plus, let's say that this is the time 1, local, and type should be time. And then we can select 10. Initial value should be 10, and then drag. And let's delete this one and connect it.
Все, я понял.
Окей.
Okay. So there are two types of how to create a time variables. Okay, so now if we again stop and build the PLC, incompatible data. Maybe we should have the same like this. Yeah. So to create the time, this is how the Beremis understand that this is the time variable. So you have to add t and 10 seconds. And then again simulate the PLC. Click on glasses, it will open the, and if you put this to true, so now back to false. And now the output will be up for 10 seconds. As you can see, the timer started.
Через 10 секунд выключит.
Yeah, so now it went back to false. So here under the library also we have the timer on delay, which is the timer that will trigger the output after 10 seconds. And then the basic timer, which is just the basic timer. We have here additional function blocks. I never use this one. Type conversions, which are we can use them. I use them a lot. So let's say that we have, I don't know, integer variable, and we want to convert it to integer. Just click and drag here. We are in the, so real to byte, and then we have this conversion. Connect the variable that you want to convert to byte to the input, and output will be converted. Okay. So numerical operations, we have just sinus and cosinus and stuff like this. A few time operations, and then piecewise operations are very often used. So AND, OR, XOR, and NOT. Selection, minimum, max, selector. So how the selector works is that we should create this one. Okay. So let me just prepare. So we have here, this will be our selector, so the gate. And then I will create a free integers, int1, int2, and int3. Okay, let's delete this. This will be, let's say that this will be 20, and this will be 100, and this will be the integer out. So if you select like this, and then another one like this, and then this will be the output. When you drag the variable in here, as you can see, it's by default it is input, so it's from this side, but you won't connect it. You can't connect it to the output.
Надо сделать.
Yeah, so click with right button and set it to the output. Okay. And then now you can connect to the output. So let's build this.
Simulated click.
Yeah. And now, as you can see, when the gate is 0, it will use the first input. But if I click this and put it to true, the output will be 100.
Yeah.
Okay, so back to false. Okay. So this is how this, yeah?
Please, PID regulator.
PID. Okay, I don't know if PID is... not sure if how this one is, but yeah, okay, I will explain it, but I will use I created my own PID regulation. I don't use this one, so I will show you how to use my PID regulator. So okay, we can continue to creating a new function block. So now we have a program, and then we can create a new function block also. So to create a new function block, click on plus, and let's say that now we have function block 1, and language will be I will be using this time structured text, and click OK. And then, as you can see, it appeared the same as the program. So the function, the variable section, and under we have the output section, missing the programming section. So basically how the function block works is I will add here 2 variables which will be inputs. So the function block have a few more different types. So the input, output to the function block, basically it can be in and out, and the same as before, we have external variables and local variables. So the input one will be input, and let's say that it is Boolean, and add another one, and I will just create another output, which will be integer. So what I want to do now is that if the input 1 is selected, then I will set the output to 100, and if input 2 is selected, 2 is selected, then I will put the output to 200. So I'll just, maybe just before we went for this, to show you how the function block works, we should check the syntax of the. So this is how the syntax looks like. Do you know the structured text programming, or you are not familiar with the structured text? So, okay. All right. So the if syntax is basically, we have here the if, and then the how is the comparison, and then if this comparison is true, we will go inside we will set fan to 0, and then you have else if, and then so we have also case when the keypad is 1 or 5, the display will display temperature. If the keypad is 2, we will display fan speed. We have for loop. As you can see, we have from 0 to 10 by step 1, and then showing something. We have while, repeat, and exit. Okay, that's it. And if I click again back again to the Beremis, now what I have created, if the input 1 is selected, it will put the output to 100, and else it will put the output to 200. So if I want to use this function block, click on user-defined pose. As you can see, this function block 1, which is here, is also appeared here, and if I want to use it, I just drag and drop into the program, and then we have here 2 inputs and 1 output. So I will just connect Boolean variable 1 and then Boolean variable 2. Create a power rail, which is left power rail, and then I will create another output integer. So drag in here, create an output, and now we have function block. So stop the PLC simulator, build the project. Okay, successfully. So simulate the PLC. Click on glasses. So now none of the Boolean variables are set to true, and if I set this one to true, the output is now 100, and if I release it back to false, and if I click the second input to true, the output is now 200. So this is how to use the function blocks. Okay.
Yeah.
So you asked how the speed regulator works. Let me just open it. Good. Okay. Speed. Okay. So this is my speed regulator. I won't go into details into the structured text code because it will take too much time. But here under the program, if I drag and drop speed regulator, as you can see, we have a lot of the inputs. So what's happening? I will just
delete.
Yeah, okay, just move this. Okay, so we have here okay, we should we connect all the inputs or just to tell you how it works? What do you want me to do? Okay, let's create the inputs so this one will be set point. I think this is the so the real value. This one will be the set point. Have the outst value. The reverse, I will just create boolean, it should be reverse. Then would manual can, then we have to check what is manual reference is real. So this one is real. Real, okay. Per and E. Okay. This one's not needed that band out max. I will just set it to 1000. This one will be 0. Cycle time, let's put it to 1 second. This one is real variable, like this. Okay, so that's about it. Okay, so save, stop, build the project. simulate. Okay, so let's say that we have now the set point, which is the
50.
Yeah, okay.
Oh.
So the 5,000, so 50% of the fan speed. Okay. And let's say that our actual value is 6,000. Then we have P, which is, I don't know, 50. This one will be 25. Okay, it's working very fast. But now if I
Насчет
put
этих 6000 и 5000 все понятно?
Да, да, конечно.
Да? Ну, так я на всякий случай, потому что... Угу. Окей.
Okay, I'm just wondering why it's working so fast.
Вот здесь бы хорошо вот этот set-point сделать периодическим, и тогда видно выход было бы. Вот о чем я тогда еще и спрашивал.
Угу.
Это видно, как работает. Окей. Good run. Просто тут вот на выходе либо 0, либо вон там 10 тысяч.
Okay. So, yeah. As you can see,
Yeah, okay.
So basically how this works is the P and I gain is how fast is it's hard to simulate this when you don't have the real fan and the real actual value. So basically here you have the set point value and then out actual value. The reverse is that the PID regulator is working in the opposite way. So now let's say that now it's working. Now it's putting the regulator to lowering down. So if I force the hold to true, it will hold the output to where it is, and if I release it back to false, then the regulation will start back to normal. The manual variable, so if I put this to true and then set the manual to the 7,000, the output will go to 7,000. Back to and then false. So now it's again working with the regulation. When we put the manual to false, and then we have just here maximum output and minimum, which is here 0% and 100% for fan speed, let's say. And then the cycle time that the PID is changing every 1 second. Okay, so this is it about the PID regulation. Is this what you wanted to hear, or you want something else to discuss?
Не понял.
Excuse me?
No.
Okay, good.
Ну вот пока только один вопрос. Active value periodical.
Так, еще раз я...
Ну вот это вот active value, который у нас там 4960 или сколько там, вот ее как-нибудь можно сделать, там, допустим, от 4 до 6 тысяч вот в симуляции? Пока вопрос один.
Act value, что сделать с ней?
Ну, чтобы она периодически менялась от 4 до 6 тысяч.
А зачем это нужно?
Как зачем? Чтобы посмотреть, как ведет себя пид-регулятор.
Все, я понял. На симуляторе на этом, да?
Да.
Все. Денис, can we change act value to look how acts PID regulator?
So yeah, I will just a second. I will just so the output is real. Okay. I will just create another output. This output connected here. Okay, stop build. So we can see on the graph this variable. Okay, so simulate. Okay, now we have to change it again. So let's say that the set point is like before. And now I will just output. Okay. So now when we set it to like this,
Не, по-моему, он не понял.
No. Can we make act value changeable
no, yeah,
to look how it will act for PID to PID regulator?
that's why I said that it's hard to simulate the PID regulator without the real fan. It's hard to simulate this actual value. I don't know.
Ну, он говорит, что это сложно сделать.
Нельзя. Ну, я и ковырялся, что и смотрю.
Окей, understand.
Yeah, okay, good. So that's about it, about the PID regulation, okay? So, what else do we want to show? So, I was explaining you before about the Modbus. Yeah, and so to find the Modbus, here are the coils. These 4 on board MC8. We have here the coils holding register discrete input registers. And if we click on plus, we can actually the same as these input and outputs, we can just drag and drop coil into the program, and that's it. And now we have the coil here, which is type is bool and location. And then this is on MC8, and then we have to configure another controller to call this coil, and this coil will be sent into the network. So this is just how to use the network Modbus variables. Okay.
Thank you.
Just checking if it's something that I missed. Okay, so we can check the program which I have created you. So this SBT group children's camp.
Да. Максим, я так понял, да. Просто мне...
Think it is
Dennis.
Yeah.
Please break HUAC. Yeah. Ventilation, condition.
Excuse me?
HUAC проект.
HUAC project, yeah. So what exactly do you mean? So the fan configuration and regulation and stuff like this.
Не понял.
Tomislav. Tomilo. Tomislav.
Сергей. Отошел, наверное.
He's not here, I guess. Let's say Tomilo's name is Sergey.
Подождите, а что происходит?
Okay. Let me check. HUAC project.
Может, значит, проверить надо. Все.
Yeah, I have the water-cooled supply unit. I'm not sure if this is water-cooled, but has to be something.
Please email.
Yeah? Email.
Yeah.
Do you want me to send it to you? What do you mean with email?
Dennis, we will collect all questions and I'll send you.
Can you ask what's the name of the colleague?
Да. Сейчас, да, в процессе. Сейчас буду в другую комнату, ребята, не мешать.
Tomilo. Send me. Okay. I'll send you. But I'm not sure if I have it on MC8. Let me check it. Just a second.
Сейчас, тогда, ну, конечно.
Yeah.
Алексей, Сергей, да, а я думал, что вы там в конференции что-то сейчас мне все, надо было сразу мне позвонить. Не. Все, сейчас, секундочку. Так, все, потому что вот уже больше часа все идет, а я был уверен, что... Да. Да, а я увидел, что в меню там 3 человека, да, и я поэтому... Так, все, сейчас, секунду. А вы ему отправляли на свои скайпы? Алексею, надо было, я думал, что вы связались с этим. Все. Так, быстренько мне в Томило в Виктория, да, пришлите свои, я вас добавлю. Все. Сейчас WhatsApp, да, сейчас скину. Угу.
Okay, Dennis.
Dennis, look, two guys weren't joined. I discovered it just now. We can proceed and start from the beginning for them. How do you think?
Today or?
Today, yes.
Or
look,
or we can.
I think so. Let's continue this session with Andrei, and I connect two guys.
Create another session with
another, but if you can today, okay?
Yeah, okay.
Okay. Okay. Good. So continue.
Yeah. So basically, how is the name of the colleague? Andre. Ne.
Yeah.
Yeah. I sent you the example of the program. For the Hvatk.
Yeah.
I suggest that you ask the question that you have before, Tomilo.
Сергей, ну я так понимаю, мы закончили, да? Если Сергей еще с нами.
Because I think that I went through the basics that's needed for the
Денис,
yeah.
project pictures. Yeah? Test.
Yeah, I can see them. Yes. Huh. Oh, I don't understand this language.
Ну, да. Все, окей, да, все тогда. Да, все, сейчас шлю. Ага, все.
Сергей, вы еще с нами?
Да. Ага.
Ну, в принципе, что, мы как бы тогда закончили. Спасибо всем большое.
Так,
Денис,
что я хочу сказать? Все вопросы со скриншотами, с подписями, да, вот, и мы все...
Да нет, тут все, на все вопросы в процессе были даны ответы, которые я хотел задать. Ну, по мелочи я уже тогда, если что, к вам.
Ага, конечно, да.
Сергей, единственное, что вот я у Дениса прошу там выцегнуть сам проект центрального кондиционирования какой-нибудь есть, я бы на его примере быстрее бы разобрался.
Все, я ему вышлю схему вот какого-нибудь...
А можно к вам, если у вас же там, вы помните, вы мне Ставрополь прислали, и вот там как раз, вот картинку я оттуда-то взял, из Ставрополя. Может, у вас там есть уже?
Окей.
Вот любую другую, а я бы разобрался.
Все, договорились. Да.
Большое спасибо. Денис.
Yes.
Thank you.
Dennis, look, I'll send you two addresses, two guys to join and start from beginning, okay?
Yeah, okay.
Товарищ не смог подключиться, ему по новой, да?
Two guys, we lost two guys.
Так, все, я отключаюсь.
Да, окей.
Сергей, спасибо большое. Ну, с вами на связи.
Не за что, да. Железочку пришлем, чтобы...
Вообще шикарно было бы. Спасибо. Всего доброго.
Хорошо, да, все.